Hi, and welcome to another edition of BC Theory. So today we're going to expand what we did last time on propositions and variables, and that we're going to make the variables more interesting. So we're actually going to be talking about something called quantifiers. So what is a quantifier? It's basically saying something about when the proposition is actually true, depending on certain conditions of the variable. So for instance, if we have the proposition P to be the statement x squared is at least 100. So, and here what I mean is that x is a variable. Okay, so when is this proposition true? Well, it depends on the value of x. So if x is, let's say, 10, then this is obviously true. 10 squared, which is 100, is at least 100. But if x is 1, then it's not actually bigger than 100. 1 squared is not bigger than 100. So what we want to say here is that for certain values of x, then the proposition is true, or maybe we want to have a proposition where we have every single possible valuation of the variable to be true. So if I said for every possible x, x squared is at least 100, that is not true because I can just put in 1 or 0 or something. But if I said there exists some x, such that x squared is at least 100, then that is true because I can find, well, 10 is a perfectly valid value of x such that x squared is at least 100. So there are two quantifiers that we're going to introduce. One of them is called forall, and the abbreviation is an upside down A. I'm not sure why they use an upside down A for this, but the other one is exists, and that one is a backwards capital E. Again, I don't know why it's backwards E, but anyway, I know it's exists, but I don't know why it's backwards. Anyway, so if we look at inserting these quantifiers onto this proposition here, well, then what we would have to do is we would have to quantify one of the variables in the proposition. Okay, so the only variable in this case is x, so we would have to attach it to the x here. So if I said for all x, x squared is at least 100, then this is saying for every possible value of x, x squared is at least 100. One thing that we should note is, well, what is x actually quantified over? If I had, say, for example, if I had a set A to be the integers 10, 11, 12, etc., and I said that for every x in A, then this statement would actually be true because every single value of x in this set, maybe I should make it actually a set first. So this is a set. So every possible value in this set, if I stick it in for the value x here in this proposition, then x squared is actually at least 100, no matter what, because I have this set. So the set that you quantify over is actually really important too. So if I instead said, okay, forget about that A, I'm going to quantify instead over the real numbers, then this statement is false, right? Because again, we could just pick 1 as an example. And of course, if I just had this for exists, then I would equivalently say exists x such that x squared is at least 100. So the key here is that this part is where the proposition goes, and this part is where the quantifiers are. And we could have more than one quantifier if possible. And if this one happens to be quantified over the real numbers again, then this one would evaluate to true. Because just like before, I could just pick x to be 10 because it's just some value in the real numbers for which the proposition is actually true. Okay, so that's a way to introduce what a quantifier is. So let's actually look at some of them. let's look at an example. So let's actually have an example where we quantify over two variables. So let's say we have for all x and y, and we're going to quantify over the real numbers here. It's the case that x plus y is at least x. Okay, so this is, whatever this represents, this is a valid statement that I can make. I have quantifiers at the front over two variables in this case, and I have some statement that involves them. Well, this says that for every value of x and y, the value of x plus y is at least x. But we can actually see right away that this is actually false. Why? Well, suppose that y is a negative number. Then x plus y is less than x, but this is saying that it's at least x. And the whole statement is saying for every choice of y, this will hold. But we just found the counterexample. Any negative value of y will work to show that it's false. So this tells us that this statement is false, and the counterexample is a y any negative number. Any one that you wish. You can make this more formal, but it's not. There's no really point to actually doing that. Okay, and one thing to note here, if you want to disprove something, show that something is false, just find one counterexample. You don't need to develop a whole theory and prove that it's false. Just find one counterexample to show that it cannot possibly be true. If you want to show it's true, then you have to prove it. But if you want to show that there's a counterexample, just give one and don't think about it anymore. It's a mistake that a lot of students make. They think to show that something's false, you have to prove something. No, just find a counterexample. It makes things a lot easier. Let's do a very similar one. So here I'm going to have for all x in the real numbers, and then now I'm going to have exists y in the real numbers, such that x plus y is at least x. Okay, so this is saying no matter what value of x I pick, there is some y that I can pick such that x plus y is at least x. So this one is true. And how do we know this? We can just pick y to be at least 0. Or any number at least 0 would work here. Because if we have y to be even equal to 0, that's fine. Then x is always at least x for any choice of x that we have. Okay, so that's a simple example of where the quantifier actually really matters here. So where exists and for all really make a difference here. Okay, so what about negation? Or what things can we do with propositions? So let's just say that I have a proposition right here. For all x, we have some proposition, p of x right here. Okay, so what if I said I'm going to put a negation, let's make that a different color. I'm going to put a negation on the front of that and negate the whole thing. Then this is saying for all values of x, the proposition is true, but this is saying that this whole thing is, the truth value is reversed. So let's actually think about this. The only way that this can be true is if the x variable satisfies the proposition for every choice of x at all, for every single one. So this is saying that there exists some value of x for which it is false. Okay, because if there didn't exist an x for which this proposition is false, then this whole thing would be true. But this negation would make that false anyway. So this is actually equivalent to saying that there exists an x such that we put the negation on the proposition now. Okay, so we're kind of distributing the negation across the two things on the inside, across the quantifier, so it switches from for all to exists, and if we had exist there, it would switch to for all. and then we're going to apply the negation onto the proposition itself, and that's what we get here. And you think, why would we even care about this? It actually shows that all that we would need to do is to find one x such that the value of x is, the p of x is false, versus showing that we have to look at every single value of x and then look at the negation of that. This is a much easier statement to understand. We just got to find one x that makes the proposition false. Okay. What else can we do? So let's actually do something a little bit more complicated. Suppose we have, for all x, we have that p of x implies that q of x and r of x. Okay. And let's just put a big fat negation on front of all that. Okay, so what are we going to actually do here? So this is saying for every value of x, p of x implies q of x and r of x. So the only way that this thing would be, let's actually think about it. So this thing would only be false on the inside if p of x is true and one of q and r is false for the same value of x. So let's actually just start working our negation through the proposition and see what happens. Well, we know from before that if we have a negation with a for all, we would change that to exists. So we have exists x and then negation of this whole thing. So I'm just applying negation to the whole big formula that we have here. Whole proposition, I mean. And then, so now what do we got to do? Well, what we got to do is we got to apply the negation onto the implication here. And what we saw before is that this is equivalent to exists x. So this part is exactly the same. And it turns out it's equivalent to saying p of x and the negation of this side over here. So, which is q of x. Maybe I'll do that in a different color. So, yeah, and the negation of qx and r of x. Okay, so all I'm doing here is I'm applying the negation across these, and it turns out that it's equivalent to saying that the p of x unnegated and the negation of the right side. So let's actually be sure of that. If both of sides are true, then let's see. Yes, let's see. So this would be, so if this is true, then and this is true, then the implication would be true, the negation would make it false, and let's see, this is true, and this thing without the negation is true, and then the negation makes it false. True and false is false. And you can verify it for the other three that it actually is equivalent logically to the original that we have here. Okay, so then what do we got to do? We got to have the same thing over here. And then we got to distribute the negation across all of the pieces in here. So what we're going to get is, we saw this before, not q of x or not rx. Okay, so when you apply negation across an and here, each of the pieces become negated and the sign is flipped, the operation's flipped from and to or right here. Okay, so that's all that we're going to talk about for quantifiers. They're actually really useful tools to be able to understand when propositions are actually true and when are not. And they're really concise because we can just write two characters to say for all something or there exists something. And there's some more that we can talk about, but this is the basics that we'll get into for now. So I hope that was interesting. Leave interesting propositions and quantifier statements in the comments. As always, please like and subscribe to the channel. It really helps us out. There are many links in the description if you want to support the channel, such as through our Patreon or our Discord server. And as always, I'll see you next time.